Hey guys, what's up? This is Ujjwal Kumar Sen and you're watching Ujjwal Kumar Sen English YouTube channel. So guys, in this session we're going to discuss few more questions. Definitely you have seen, right? 241 to 250 questions. 10 questions we'll discuss, right? And one more thing guys, we have launched our test series, that is NLC test series for technical as well as for non-technical. For technical we are providing only mechanical, non-technical anybody can get it, right? So in the non-technical section, my dear, we are providing 65 plus tests including topic wise as well as subject wise. Link is in the description. And for technical we are providing 10 full length tests for mechanical technical part only. Link in the description as well as in the first comment. So guys, let's get started. Which of the following gases has the highest value of characteristic gas constant R? My dear, to solve this question we need to know the relationship between characteristics gas constant and, my dear, gas constant, right? So we know that universal gas constant is equal to molecular weight multiple characteristics gas constant. Therefore we can write it capital R is equal to universal gas constant by m, right? What is the value of universal gas constant? 8.314 joule per mole Kelvin. This is the unit, right? Now guys, think about it. This is molecular weight. More molecular weight means less characteristics gas constant, because if it will increase, the whole value will decrease. That means R will decrease, right? That means we have to find out among all the four options which one is having less molecular weight. Lesser the molecular weight, more will be the characteristic gas constant. From this equation also we can understand, right? Now in nitrogen, what is the value of molecular weight? 14. Carbon dioxide 32 plus 12 44. Sulfur dioxide 32 plus 32 64, and oxygen 32. That means nitrogen having least molecular weight among all the four options we have given. So that the answer for this question will be what? Option A is the correct answer for this question. Question number 242. During an adiabatic process, the pressure P of a fixed mass of an ideal gas changes by delta P. Its volume V changes by dV. The value of dV by V is given by. So we have to find out value of dV by V. We know that adiabatic process means PV to the power gamma is equal to constant. Now differentiate both sides. So what we can write? P, first we are doing with respect to V, gamma V to the power gamma minus 1 dV. Now we have to do with respect to P, right? So dP V to the power gamma, and for constant differentiation will be what, my dear? 0. Now we are dividing, my dear, for both sides, LHS as well as RHS. What we are dividing basically, let's say, yes, V to the power gamma, we are dividing with V to the power gamma. And one more thing, my dear, we can do here to to make it very simpler for us. We have to divide with V to the power gamma and P, right? We have to do that. If we can do that, we can easily solve this question. All right. So my dear, now look at the equation. What V to the gamma and P. So for this part, P will get cancelled, and V to the power gamma, V to the get cancelled. So V to the power minus 1. Therefore we can write this as gamma, right? And dV by V we can write like this. And for this case, my dear, V to the gamma, V to the gamma can get cancelled. So plus dP by P. So what we can write? Gamma dV by V plus dP by P is equal to 0. Now let's further simplify. Gamma dV by V, gamma dV by V is equal to minus dP by P. What we have to find out? dB by V. Therefore we have to send this gamma to this side. So dV by V is equal to minus 1 by gamma dP by P. So answer for this question will be what, my dear? Option B is the correct answer for this question. Question number 243. A heat engine is supplied with 278 kilowatt of heat, a constant fixed temperature of 283 degrees centigrade. and heat rejection takes place at 5 degrees centigrade. The engine reversible if the heat rejected in kilowatt is. So we have to find out this, right? And the engine is reversible. It is talking about the engine is reversible, right? So for this, my dear, we have to draw a diagram of heat engine. Let me draw, right? Diagram of heat engine. Drawing a diagram of heat engine, right? So this will like this. So here, my dear, 278, right? We have to find out W and we have to find out then HR, right? So efficiency is equal to what, my dear? 283 minus 5 by 283 plus 273 is equal to what? Output by input. Output input how much? 278. From here, find out W. What is the value of W we are getting? That is what is the value we are getting, my dear? 139 we are getting. But yet they are asking to find out heat rejection. That means this part. So we know that input is equal to what? Output plus heat rejection. Therefore, heat rejection is equal to input minus output. So input is 278 minus 139 is equal to what value we are getting? 139 we are getting. 139 kilowatt would be answer. So option A is the correct answer for this question. I hope you are getting me. Now guys, let's move on to the next question. Question number 244. Neglecting changes in potential and kinetic energies, the shaft work during a steady flow process is given by, right? So that is very, very important, my dear. So my dear, there are two processes we got. One is closed, another is steady flow process, that is open. In closed process, work done is equal to PdV. And in case of open, work done is equal to minus VdP. So here steady flow means it is talking about open system process, open process, right? So in that case, my dear, answer will be what? Option B is the correct answer for this question. Question number 245. Heat supplied to a system equals the work done in case of non-flow process carried out. So for this, we have to write down the equation of first law of thermodynamics. That is what? dq is equal to dw plus du. Now, when dq is equal to dw, only and only if du is equal to 0. When du is equal to 0, for that we have to write the formula. Du is equal to mcv dt. One trick you need to remember. What trick you can use to remember the formula of this? What we got, my dear, after u? V. That is why du is equal to mcv dt, right? Remember that. This is a trick, my dear, right? Now, my dear, when this term will be 0, when we'll have dt is equal to 0. When dt will be 0, when t is equal to constant. When t is constant, in the process of isothermal only. Therefore, option C is the correct answer for this question. I hope you are getting me. And this equation, my dear, very, very important. I have seen this equation is used by a couple of times. You cannot even imagine. Even maybe we'll use again in upcoming questions, right? If two liquids at different temperatures are mixed, then final temperature of the mixture of liquids can be obtained by using 0th law of thermodynamics, first law of thermodynamics, second law of thermodynamics, and third law of thermodynamics. So my dear, here we have to use the concept of law of conservation of energy. That means energy is conserved, doesn't matter what we'll do. So if we will use that concept, we can find out answer of this question. Therefore, we have to use the concept of first law of thermodynamics. The other name of first law of thermodynamics is what? Law of conservation of energy, as well as Joule's law. Remember these two terms. Question number 247. One of the extensive properties of a thermodynamic system amongst the following is. So we have options, right? Among all four options, which one is an extensive property? Now let's understand what is an extensive property. If any property, thermodynamic property, is depend on mass, is known as what? Extensive property. Density is what, my dear? Mass division volume. Both are extensive, volume as well as mass. Therefore, this term will be what? Intensive property. Always remember this. Even pressure, force by area, extensive by extensive. Therefore, it is an intensive property, right? Temperature is an intensive property because it is not depend on mass. Only volume is an extensive property. Now maybe you will tell me, so how could it possible? You told me that it is depend on mass, but volume is not depend on mass, right? But I will tell you another way. If there is a body, right? If we'll divide this body into two parts, the properties will change. Those are what, my dear, extensive property. Those properties will not change. They are what, my dear, intensive property. So volume of this body will change, right? Volume by 2, let's say volume by 2. That means volume is an extensive property. Therefore, option B is the correct answer for this question. Question number 248. Which property is an intensive property of the system? My dear, what is an intensive property? Which is independent, ion, match with ion, independent of mass. Which is independent of mass is known as what? Intensive property. So entropy, let's run the formula, write the formula, dQ by T. It is like energy, right? Heat is not an energy, but it is type of energy. Its also unit is joule or kilojoule, right? That means energy, any type of energy matter we have, that is an extensive property because it is dependent on mass. So entropy is an extensive property, kinetic energy is an extensive property. Now volume is an extensive property, just we have seen. Specific enthalpy, dear, only enthalpy is an extensive property, only enthalpy. But specific enthalpy means, let's write down, enthalpy by mass. So extensive by extensive, what, my dear? Intensive property. If a specific term will come just before any energy, then that is an intensive property. Remember that, because any energy is what, my dear? Extensive property. If that energy will be divided by mass, then that property will become intensive property. The exactly thing it is happening. Enthalpy is a kind of energy. What type of energy is this, my dear? It is a store energy. Internal energy also a store energy, but heat, my dear, it is transfer energy because of temperature difference. Question number 249, another amazing question. A closed balloon containing 10 kg of helium receives 5 kJ per kg of heat. During this process, the volume of the balloon slowly increases by 0.2 meter cube at constant pressure of 100 kilopascal. The change in internal energy in kilojoule is, we have to find out change in internal energy. So we have to use that equation, that is what? dq is equal to du plus dw, right? We have to use this equation. Now we have to find out du, right? Just multiply these terms, we'll get du. That is what, my dear? 50. du is 50. Now we have to find out du. For finding du, we have to find out what, my dear? dw. So we know dw is what, my dear? P dv. So P is what, my dear? 100. dv is what, my dear? 0.2. So it is what, my dear? 20 kilojoule. So dw is 20 kilojoule and dq is 50 kilojoule. So du is what, my dear? 50 minus 20, that means 30 kilojoule. Therefore, answer for this question will be what, my dear? Option C is the correct answer for this question. I hope you got the point. Now let's move to the question number 250. An adiabatic process in a thermodynamic system is one in which there is, so my dear, in case of adiabatic process there is no heat transfer. That means heat is constant. So if you look at the option A, a limit heat transfer, no. Option B, no heat transfer to or from the system through the boundary. That's right. So option B, therefore option B is the correct answer for this question. I hope you got my point. So guys, thank you very much for watching this session, and this is about thermodynamics. We'll start another subject, maybe I will start, right? So for NLC test series, my dear, for tech as well as non-tech, you'll find the links, both the links in the, my dear, description. For non-tech, we are providing 65 plus test topic wise, part wise as well as subject wise, and for technical we are providing 10 full length mechanical test series. For both the link you'll find out in the description. For mechanical you'll find out the link in the first comment. Thank you very much for watching. Bye bye, see you soon. God bless you all.